Since 2005, the next size up rule cannot be used for transformer secondary conductors. This implies for a 400 amp service, you would need one 600 mcm or two 3/0 copper conductors per phase, and double that for an 800 amp service. However, an exception exists for circuit breakers listed and marked as suitable for use with the next size up rule. If you are using a circuit breaker that has been listed and marked as suitable for use with the next size up rule, you can indeed use the next size up rule to determine the size of the transformer secondary conductors. Conversely, if the circuit breaker has not been listed and marked accordingly, then you must adhere to specific conductor sizing based on service ampacity. For a 400 amp service, you will need two 3/0 copper conductors. For an 800 amp service, you will require four 3/0 copper conductors. This means that, in most scenarios, ordering special lugs on a circuit breaker to meet requirements is unnecessary unless your circuit breaker lacks the specific listing and marking for the next size up rule. To reiterate, the need for special lugs hinges on the circuit breaker's listing status, specifically whether it is approved for use with the next size up rule, which is outlined in the National Electrical Code section 250.21c. This section of the code addresses the grounding requirements for alternating current systems. Understanding grounding is paramount for electrical safety and code compliance. The code mandates grounding to limit voltage imposed by lightning, line surges, or unintentional contact with higher voltage lines, and to stabilize voltage to earth during normal operation. Grounding also facilitates overcurrent device operation in case of ground faults. Grounding electrode conductors connect the system's grounded conductor to the grounding electrode, ensuring a low impedance path to ground. Proper sizing of these conductors is crucial to handle fault currents effectively. Grounding electrodes can include metal underground water pipes, metal frames of buildings, concrete encased electrodes, and ground rings. The selection depends on site conditions and code requirements. The effectiveness of the grounding system relies on proper installation and maintenance. Regular inspections and testing are essential to verify the integrity of grounding connections and the resistance to ground. Addressing grounding system issues promptly is crucial for maintaining electrical safety and code compliance. The National Electrical Code Article 250 provides detailed requirements for grounding and bonding. Adherence to these requirements is vital for ensuring electrical safety and preventing hazards. Grounding and bonding are essential elements of electrical safety. Understanding the requirements and best practices is crucial for electrical professionals. This explanation highlights key aspects of grounding and bonding, emphasizing the importance of code compliance and safety in electrical systems. The National Electrical Code, or NEC, plays a vital role in electrical installations. The NEC is a comprehensive set of standards and guidelines designed to ensure the safe installation and maintenance of electrical systems. It covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Compliance with the NEC is essential for protecting people and property from electrical hazards. The NEC is updated every 3 years to reflect advancements in technology and changes in industry practices. Electrical professionals must stay current with the latest edition of the NEC to ensure their work meets safety standards. State and local jurisdictions often adopt the NEC as the basis for their electrical codes. However, they may also make amendments or additions to address local conditions or specific needs. Understanding the electrical codes applicable in your area is essential for compliance. The NEC provides detailed requirements for various aspects of electrical installations. These requirements are based on established safety principles and industry best practices. Adhering to the NEC requirements helps minimize the risk of electrical shock, fire, and other hazards. The NEC covers wiring methods, including the types of conductors, raceways, and cables that are permitted for different applications. It specifies the ampacity of conductors, the size of overcurrent protection devices, and the methods for installing wiring in various environments. The NEC also addresses grounding and bonding requirements to ensure a low impedance path to ground for fault currents. It covers the types of grounding electrodes, the size of grounding conductors, and the methods for bonding metal enclosures and equipment. Overcurrent protection is a critical aspect of electrical safety. The NEC provides requirements for selecting and installing overcurrent protection devices, such as circuit breakers and fuses, to protect conductors and equipment from overloads and short circuits. The NEC includes requirements for equipment installation, such as the spacing around electrical equipment, the methods for supporting equipment, and the protection of equipment from physical damage. The NEC is a complex and comprehensive document, and it can be challenging to navigate. However, there are resources available to help electrical professionals understand and comply with the NEC. These resources include training courses, seminars, and online resources. Understanding and complying with the NEC is essential for electrical safety. By following the NEC requirements, electrical professionals can help ensure that electrical systems are installed and maintained safely. This section provides an overview of the NEC and its importance in electrical installations. Adhering to the NEC requirements is crucial for protecting people and property from electrical hazards. Now let's delve deeper into conductor sizing. Conductor sizing is crucial in electrical installations to ensure safety and efficiency. Undersized conductors can overheat, leading to insulation damage, voltage drop, and potential fire hazards. Conversely, oversized conductors can be unnecessarily expensive. Several factors influence the selection of appropriate conductor sizes. These include the ampacity of the circuit, the ambient temperature, the number of conductors in a raceway, and the type of insulation. The ampacity of a conductor is its current carrying capacity as specified in the National Electrical Code, or NEC. The ampacity must be sufficient to carry the load current without exceeding the conductor's temperature rating. Ambient temperature affects the conductor's ability to dissipate heat. Higher ambient temperatures reduce the conductor's ampacity, requiring larger conductors to maintain safe operating temperatures. The number of conductors in a raceway also affects ampacity. When multiple current-carrying conductors are installed in a raceway or cable, their ampacity must be derated to account for the increased heat generated. Different types of insulation have different temperature ratings. Conductors with higher temperature ratings can operate at higher ampacities. The NEC provides tables and guidelines for determining conductor ampacity based on these factors. These tables specify the allowable ampacities for various conductor sizes, insulation types, and installation conditions. Voltage drop is another important consideration in conductor sizing. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. Longer circuits require larger conductors to minimize voltage drop. The conductor material also affects voltage drop. Copper conductors have lower resistance than aluminum conductors, resulting in less voltage drop for the same current and length. Selecting the correct conductor size is essential for electrical safety and efficiency. By considering the ampacity, ambient temperature, number of conductors, insulation type, and voltage drop, you can ensure that conductors are adequately sized for their intended application. Here is an overview of conductor sizing, emphasizing the importance of safety and efficiency in electrical installations. Proper conductor sizing is crucial for preventing overheating, voltage drop, and other hazards. Let's explore overcurrent protection. Overcurrent protection is a critical aspect of electrical safety, designed to protect conductors and equipment from excessive current flow. Overcurrent can result from overloads, short circuits, or ground faults. Overcurrent protection devices, such as circuit breakers and fuses, interrupt the flow of current when an overcurrent condition occurs. Circuit breakers are electromechanical devices that trip and open a circuit when an overcurrent is detected. They can be reset and reused after the overcurrent condition has been cleared. Fuses are single-use devices that melt and open a circuit when an overcurrent occurs. They must be replaced after they have blown. The selection of appropriate overcurrent protection devices depends on several factors, including the ampacity of the circuit, the interrupting rating of the device, and the type of load being protected. The ampacity of the circuit is the maximum current that the circuit is designed to carry. The overcurrent protection device must have an ampacity rating that is equal to or less than the ampacity of the circuit. The interrupting rating of an overcurrent protection device is the maximum fault current that the device can safely interrupt. The interrupting rating must be sufficient to handle the available fault current at the point of installation. Different types of loads require different types of overcurrent protection devices. For example, motor circuits require overcurrent protection devices that are specifically designed to handle the inrush current associated with motor starting. The NEC provides detailed requirements for overcurrent protection. These requirements specify the types of overcurrent protection devices that are permitted for different applications, the ampacity ratings of the devices, and the methods for installing the devices. Proper overcurrent protection is essential for preventing electrical fires, equipment damage, and personal injury. By selecting and installing overcurrent protection devices in accordance with the NEC requirements, you can ensure that electrical systems are adequately protected from overcurrent conditions. Here is a discussion of overcurrent protection, emphasizing its importance in electrical safety. Proper overcurrent protection is crucial for preventing electrical fires, equipment damage, and personal injury. Bonding and grounding are related but distinct concepts in electrical safety. Grounding creates a low impedance path for fault currents to return to the source, facilitating the operation of overcurrent protection devices. Bonding connects metal parts of an electrical system together to create an electrically conductive path. This path ensures that all metal parts are at the same electrical potential, reducing the risk of electric shock. Grounding electrodes are used to connect the electrical system to the earth. Common grounding electrodes include metal underground water pipes, metal frames of buildings, and ground rods. Grounding conductors connect the grounded conductor of the electrical system to the grounding electrode. Bonding conductors connect metal parts of the electrical system together. Bonding is essential for preventing voltage differences between metal parts, which can create a shock hazard. Bonding also helps to reduce electromagnetic interference. The NEC provides detailed requirements for grounding and bonding. These requirements specify the types of grounding electrodes, the size of grounding conductors, and the methods for bonding metal enclosures and equipment. Proper grounding and bonding are essential for electrical safety. By following the NEC requirements, you can help ensure that electrical systems are properly grounded and bonded, reducing the risk of electric shock and other hazards. Let's look into bonding and grounding, emphasizing their importance in electrical safety. Proper grounding and bonding are crucial for preventing electric shock and ensuring the safe operation of electrical systems. Now let's cover electrical safety. Electrical safety is of utmost importance in any electrical work environment. Following safety procedures and using appropriate personal protective equipment, or PPE, are essential for preventing electrical accidents. Energizing circuits before working on them is the most effective way to prevent electrical shock. Use lockout-tagout procedures to ensure that circuits remain energized while work is being performed. Always use insulated tools when working on or near electrical circuits. Insulated tools provide a barrier between you and energized conductors, reducing the risk of electric shock. Wear appropriate PPE, such as safety glasses, rubber gloves, and flame-resistant clothing when working on or near electrical circuits. PPE provides additional protection against electrical hazards. Maintain a safe working distance from energized electrical equipment. Keep yourself and any conductive objects at least the minimum safe distance away from exposed energized parts. Be aware of your surroundings and identify potential electrical hazards before starting work. Look for damaged wiring, exposed conductors, and other potential hazards. Follow proper grounding and bonding procedures to ensure that electrical systems are properly grounded and bonded. Proper grounding and bonding reduces the risk of electric shock and other hazards. Use ground fault circuit interrupters, or GFCIs, in wet or damp locations to protect against electric shock. GFCIs detect ground faults and interrupt the flow of current, preventing electric shock. Regularly inspect electrical equipment and wiring for damage. Replace any damaged equipment or wiring immediately. Never work on electrical equipment or wiring when you are tired or distracted. Fatigue and distraction can increase the risk of electrical accidents. If you are not qualified to perform electrical work, do not attempt it. Electrical work should only be performed by qualified and experienced personnel. Following these electrical safety guidelines can help prevent electrical accidents and ensure a safe working environment. Remember, electrical safety is everyone's responsibility. Here is an overview of electrical safety, emphasizing the importance of following safety procedures and using appropriate PPE. Electrical safety is crucial for preventing electrical accidents and ensuring a safe working environment. Now, let's discuss working with electricity. Working with electricity can be dangerous if proper precautions are not taken. Understanding the hazards and following safety guidelines are essential for preventing electrical accidents. Always assume that electrical circuits are energized until proven otherwise. Use a voltage tester to verify that circuits are de-energized before working on them. Never work on energized electrical circuits unless it is absolutely necessary. If you must work on energized circuits, use appropriate PPE and follow strict safety procedures. Be aware of the potential for arc flash, which is a dangerous electrical explosion that can occur when working on or near energized equipment. Wear flame-resistant clothing and use arc flash protection equipment when working in areas where arc flash hazards exist. Use caution when working with power tools and equipment. Make sure that power tools are properly grounded and that cords are in good condition. Never use power tools in wet or damp locations unless they are specifically designed for use in those environments. Avoid contact with overhead power lines. Keep yourself and any conductive objects at least 10 feet away from overhead power lines. Be aware of the potential for static electricity buildup, which can ignite flammable materials. Ground yourself before working with flammable materials. Follow lockout-tagout procedures to ensure that circuits remain energized while work is being performed. Lockout-tagout procedures involve placing a lock and tag on the disconnecting means of a circuit to prevent it from being accidentally energized. If you are not qualified to perform electrical work, do not attempt it. Electrical work should only be performed by qualified and experienced personnel. By following these guidelines, you can minimize the risk of electrical accidents and ensure a safe working environment. Remember, electricity is a powerful force that must be treated with respect. This is an overview of working with electricity, emphasizing the importance of understanding the hazards and following safety guidelines. Working with electricity can be dangerous if proper precautions are not taken. Remember to always prioritize safety. Now, let's consider permits and inspections. Electrical permits and inspections are essential for ensuring that electrical installations comply with safety codes and regulations. Permits are required for most electrical work, including new installations, alterations, and repairs. The purpose of a permit is to ensure that the work is performed by qualified personnel and that it meets the requirements of the electrical code. Inspections are conducted by qualified electrical inspectors to verify that the work has been performed in accordance with the electrical code. Inspections help to identify potential safety hazards and ensure that the electrical system is safe and reliable. The permit and inspection process typically involves submitting an application to the local building department, paying a fee, and scheduling an inspection. The inspector will review the plans for the electrical work and conduct a site visit to verify that the work has been performed in accordance with the plans and the electrical code. If the work passes inspection, the inspector will issue a certificate of compliance. If the work does not pass inspection, the inspector will issue a list of corrections that must be made before the certificate of compliance can be issued. Obtaining electrical permits and inspections is not only required by law, but it is also a good safety practice. Permits and inspections help to ensure that electrical work is performed safely and correctly, reducing the risk of electrical fires, equipment damage, and personal injury. Here's an overview of electrical permits and inspections, emphasizing their importance in ensuring electrical safety and code compliance. Electrical permits and inspections are essential for ensuring that electrical work is performed safely and correctly. Remember that following code is paramount. We will now address troubleshooting electrical systems. Troubleshooting electrical systems involves identifying and resolving problems in electrical circuits and equipment. Effective troubleshooting requires a systematic approach and a good understanding of electrical principles. Start by gathering information about the problem. Talk to the person who reported the problem and ask them to describe what happened. Check for any obvious signs of damage, such as broken wires, burned components, or tripped circuit breakers. Use a multimeter to measure voltage, current, and resistance in the circuit. These measurements can help you to identify the location of the problem. Refer to wiring diagrams and technical manuals to understand the operation of the circuit. These documents can help you to identify the correct voltage and current levels in the circuit. Use a process of elimination to narrow down the possible causes of the problem. Start by checking the simplest and most likely causes, such as a tripped circuit breaker or a loose connection. Once you have identified the cause of the problem, take steps to correct it. This may involve replacing a faulty component, repairing a broken wire, or tightening a loose connection. After you have corrected the problem, test the circuit to make sure that it is working properly. Use a multimeter to verify that the voltage and current levels are within the correct range. Keep accurate records of your troubleshooting activities. This information can be helpful if the problem occurs again in the future. Troubleshooting electrical systems can be challenging, but it can also be rewarding. By following a systematic approach and using the right tools and techniques, you can effectively troubleshoot electrical problems and keep electrical systems running safely and reliably. This covers troubleshooting electrical systems, emphasizing the importance of a systematic approach and a good understanding of electrical principles. Troubleshooting electrical systems involves identifying and resolving problems in electrical circuits and equipment. Remember that safety comes first. Let us cover electrical maintenance. Electrical maintenance is essential for ensuring the safe and reliable operation of electrical systems. Regular maintenance can help to prevent electrical fires, equipment damage, and personal injury. Perform regular visual inspections of electrical equipment and wiring. Look for signs of damage, such as broken wires, cracked insulation, or loose connections. Test the operation of circuit breakers and ground fault circuit interrupters, or GFCIs, regularly. Make sure that these devices are tripping properly when an overcurrent or ground fault occurs. Tighten any loose connections that you find. Loose connections can cause overheating and arcing, which can lead to electrical fires. Clean electrical equipment regularly to remove dust, dirt, and other contaminants. Contaminants can reduce the efficiency of electrical equipment and can also create a fire hazard. Lubricate moving parts of electrical equipment as needed. Lubrication helps to reduce wear and tear and can extend the life of electrical equipment. Replace any worn or damaged components promptly. Worn or damaged components can cause electrical equipment to malfunction or fail. Keep accurate records of all maintenance activities. These records can be helpful for tracking the performance of electrical equipment and for planning future maintenance activities. Electrical maintenance should be performed by qualified personnel who are trained to work on electrical equipment. Improper maintenance can be dangerous and can lead to electrical accidents. By following these electrical maintenance guidelines, you can help to ensure the safe and reliable operation of electrical systems. This is an overview of electrical maintenance, emphasizing its importance in ensuring the safe and reliable operation of electrical systems. Electrical maintenance is essential for preventing electrical fires, equipment damage, and personal injury. Now let us end with electrical efficiency. Electrical efficiency is the measure of how effectively electrical energy is used. Improving electrical efficiency can save money on energy costs and reduce the environmental impact of electricity generation. Use energy-efficient lighting, such as light-emitting diodes or LEDs. LED use significantly less energy than incandescent or fluorescent lighting. Turn off lights and equipment when they are not in use. Even small amounts of energy waste can add up over time. Use power strips to turn off multiple devices at once. Power strips can also help to protect equipment from power surges. Upgrade to energy-efficient appliances and equipment. Energy-efficient appliances and equipment use less energy than older models. Insulate buildings properly to reduce heat loss in the winter and heat gain in the summer. Proper insulation can reduce the amount of energy needed to heat and cool buildings. Seal air leaks around windows and doors to prevent drafts. Air leaks can waste energy and make it difficult to maintain a comfortable temperature. Use programmable thermostats to control the temperature in buildings. Programmable thermostats can automatically adjust the temperature based on the time of day or the occupancy of the building. Install solar panels to generate electricity from the sun. Solar panels can reduce reliance on fossil fuels and can save money on electricity costs. Educate employees and building occupants about energy conservation. Encourage them to adopt energy-saving habits. Conduct regular energy audits to identify areas where energy can be saved. Energy audits can help to identify inefficiencies and recommend improvements. By following these electrical efficiency tips, you can save money on energy costs and reduce the environmental impact of electricity generation. This is an overview of electrical efficiency, emphasizing the importance of using energy-efficient practices to save money and reduce environmental impact. Electrical efficiency is the measure of how effectively electrical energy is used. Reducing the amount of energy you use is good for both your wallet and the planet. Now you have a greater awareness of the NEC code about transformer secondary conductors.